permutations. So we already talked about permutations, but I actually didn't use the word yet. So Mrs. Ramsey owns 4 different CDs. This is probably old. In how many different orders can they be played? So how many decisions does Mrs. Ramsey need to make? 4. So I put 4 blanks down, yes? How many choices do I have for the first decision? 4. Then 3, then 2, then 1. So this pattern of multiplication may be written as 4 factorial. So in general, n factorial is n times n minus 1 times n minus 2 all the way down to 3 times 2 times 1, depending on what your n is. Do you understand? Like, so if n is 100, it'll be 100 times 99 times 98 times 97, blah, 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 all the way down to 1. So n represents natural numbers. What's the definition of natural numbers? The counting numbers, so you don't start with 0, you start with 1. Okay? So let's, you can only take a factorial of a positive number. Positive whole numbers. Again, it doesn't include 0. There's an actual identity for 0 coming up, and I'll show you. Okay, so 10 factorial divided by 9 factorial. So there's a lot of little tricks for this. Does everybody see that 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Does everybody see the 9 factorials actually cancel? And we're left with 10. So once you see this little pattern, you don't need to write it all out. I just wanted to show you that that's the cancellation. So what about 5 factorial divided by 7 factorial? What would that be? Not 1 over 2. 1 over 42. Why is it 1 over 5? Again, if you want, you can leave this as so the way I would recommend doing this is whatever the bigger factorial is, write it in terms of the smaller one. So 7 factorial would be 7 times 6 times 5, 4, 3, 2, 1, 5 factorial. Do you see? Then you don't have to write the rest of them out. And you see that those will cancel. And then you get 1 over 42 as your final answer. Do you see that? Okay, how about this one? 12 factorial over 8 factorial, 4 factorial. Yeah, so 8 factorial times 4 factorial is not 12 factorial, just so you know. Okay? It's not 32 factorial either. So 12 factorial, again, if you use the little technique I showed you, is write the bigger one in terms of the smaller one. So 12 factorial is 12 times 11 times 10 times 9. And if you want, you can write the 8 factorial, just so I can show you that the 8 factorial will actually cancel with that. And then we have a 4, 3, 2. If you want to put the 1, it's up to you. Does everybody see what I did? So the 4 factorial is this part. Yes? The 8 factorial canceled. So does everybody see 4 times 3 is 12, so that will cancel that 12. And 2 goes into 10 5 times. So we have 45 times 11. Or 95. Does everybody know the trick for multiplying by 11s? Yeah. Like, so 45 times 11, the outside is that 4, the other outside is the 5, and then you just add those two together like that. Okay, so n factorial over n minus 2. Does everybody remember what n factorial stands for? N times n minus 1 times n minus 2. And if you want, you can end with n minus 2 factorial because it keeps on counting down. So does everybody see those will cancel? And we get n squared minus n. How about this one? Which one's the bigger one? N minus 4 factorial or n minus 5 factorial? Which one's the bigger one? N minus 4. So n minus 4 times n minus 5, and after that they cancel. Do you see that? So you're just left with n minus 4. Okay, so I'm going to show you the identity of what 0 factorial is. Does anybody think they know what 0 factorial equals? Don't check on your calculator, that's cheating. No guesses? Undefined? What 0 factorial equals? I hear 0, I hear undefined. Okay.
It's 1. It's 1.
It is 1. I'll show you why. Okay. So does everybody see that n plus 1 factorial is equal to what times n factorial? N plus 1 times n factorial. Is everybody good with that? Because you're counting down? Yeah? So now, if I get n factorial by itself, do you understand that it would be this divided by that? So n plus 1 factorial divided by n plus 1. I just cross multiplied this down, yes? So if n actually equaled 0 and I plug it into this formula, do you see 0 factorial would be? 0 plus 1 factorial would be 1 factorial divided by 1. And what's 1 factorial equal to? 1. And 1 divided by 1 is 1. So it's actually equal to 1. Okay, the word permutations means an arrangement of objects in a different order. To permute a set of objects means to rearrange them. Many student lockers are secured with a 3-number combination lock. Knowing the 3 numbers is not sufficient to open the lock. The numbers must be used in the correct order. Do you see how order is important, right? In that example? Yes? Okay, consider the letters AET. List the different ways to arrange them. There's 6. Yes. So AET is 1. Let's rearrange them. We'll switch the E and the T around. 8. Then what? We can switch the A and the T around. So TEA. What else can we do? TAE. Then what? ETA. And then what? And then EAT, yes. EAT, very good. And so, like I heard somebody say, how did I know there was 6? There were 3 decisions to make. What letter to put in the first spot? 3, 2, 1. Or 3 factorial. After a while, you'll know that 3 factorial is actually 6. The number of ways n objects can be placed into R position is given by the formula NPR, or n with a bracket NR, is n factorial over n minus r factorial. This is a formula on your formula sheet. Okay, so the restrictions are n has to be greater than or equal to 1, and n has to be greater than or equal to r. So consider the letters A, B, C, D, E, F, G. How many permutations of 4 are possible? Okay, so we can do it the old way with the blanks. Okay, if you want. How many decisions do I have to make? 4 decisions. How many choices do I have for the first blank?
No, that's not 8, that's 7.
7, yeah. And then I have 6, then 5 times 4. Does everybody see? Yes? So 20 times 42 would be what, 840? Yes? The other way you can do it now is with this nice little formula, and that is, does everybody see there is n objects and r positions? So it would be 7p4. Does everybody see? There's 7 objects and 4 positions. So that's equal to 7 factorial divided by n minus r is 7 minus 4. So it would be 3 factorial. So do you see I get the same thing? 7 times 6 times 5 times 4, and then the 3, 2, 1 go away. Does everybody see it's the same exact thing? So I'm showing you this with smaller numbers, but when you get to big numbers, you're not going to do blanks because it's a ridiculous amount of blanks you'll be doing. You'll be using your calculator. So, no, it's kind of half and half. So does everybody want to find the P button on their calculator? On the TI-83s and 4s, it's under Math, and then toggle to the left to Probability, PRB, and you'll see an exclamation mark. You'll also see an NCR and an NPR. Okay, let's do the next example here. It says solve for n. They like asking this on the exam because it's a non-calculator thing. You have to know how to simplify n plus 1 factorial over n factorial. Does anybody know what n plus 1 factorial over n factorial simplifies to be? N plus 1. And so then n equals 6. Bam, done. Okay, how about the next one? NP2. Well, you have to know how to put it into the formula. So what does NP2 stand for? N factorial over what? Look at the formula above at the, you're supposed to take this and subtract this. So you're going to get n minus 2 factorial equals 30. Again, you can't solve when you have factorial, so you need to simplify the factorial part of it. So what does n factorial over n minus 2 factorial simplify to be? Yes, I'm going to write it as n times n minus 1 first, and then I'll write it as n squared minus n. So I'm going to multiply that so I get n squared minus n minus 30 equals 0, and that factors to be what? So what does this factor to be? N minus 6, n plus 5. So that means n equals 6 and negative 5. And remember the restriction, n has to be greater than or equal to 1. Reject. Yes? Okay, this one's a little harder, maybe, I don't know. Solve for n. So this is the one that goes in the n factorial spot. So that would be n minus 1 factorial. And what does this 2 mean here? It's going to be this minus this on the bottom. So what do we get on the bottom? N minus 3 factorial on the bottom equals 72. I'll repeat. The formula is this factorial over this minus this factorial on the bottom. Okay, so now what does n minus 1 factorial over n minus 3 factorial simplify to be? N minus 1 times n minus 2, and then after that, they cancel, equals 72. So now we FOIL this. So n squared minus 3n plus 2 minus 72 equals 0. Yes? N squared minus 3n minus 70 equals 0. What does that factor to be? 7 and 10? So n minus 10, n plus 7. Everybody agree? So n equals positive 10 and negative 7, which we will reject negative 7, right? Because again, n has to be greater than or equal to 1.
That's smart.
Yes. Okay, word permutations. How many words can be made by the word foot? So normally you would say what? You would say 4 factorial because you have 4 decisions, 4 choices, blah, blah, blah. Does everybody see that switching the O's doesn't make a new word, though? If I switch the 2 O's around, it's still foot, right? It doesn't have to be. That's why it's in quotes. It's not a real word in the dictionary. We're just saying how many. basically things, can we make arrangements of letters. So what happens here is if you have repeated letters, you have to actually divide it by the number of repeated letters factorial out of there. So let's just, to make our head around this, let's actually list all the different ways we can rearrange foot. There's lot. Well, there would be 12. Do you think we could come up with 12? So there's foot. Then there's tooth. Yeah? Now we could put the O first, maybe. O-F-O-T. O-T-O-F. Then I could probably put the F in the second one. Yes? So O-O-F-T. O-O-T-F. I feel like this is an acronym on Snapchat or something like that. No? O-O-F-T. Never mind. I thought it was a joke. Okay, let's carry on. Okay, what's another one? I put that in the second, I guess I put it in the third. O-F-T-O. O-T-F-O. It's another one. T-F-O-O. F-T-O-O. We need two more. Right? F-O-T-O. That's right. T-O-F-O. Okay, so we found all 12. So normally we would do this as it's 4 factorial because there's 4 letters, 4 decisions, 4 choices for the first, 3, 2, 1. Everybody agree? But because we have repeated O's and it doesn't matter when we switch it, we actually count double the amount. So we have to divide by the number of factorial letters repeated. So does everybody see 4 factorial divided by 2 factorial is 4 times 3, and then the 2 factorials will cancel, so we get 12 ways. So in general, a set of n objects taken together of which A1 are alike of one kind, A2 are alike of another kind. Essentially, it's the number of objects divided by the repeated letters factorial. So how many ways can we make the word geese? 1, 2, 3, 4, 5. So it's 5 factorial. How many repeated letters do I have? 3 E's. So this would be 3 factorial. So then it would be 5 times 4, which is 20. Does everybody see how I get this? Okay, try Mississippi. Try Mississippi. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 factorial divided by, there is 4 I's repeating, 4 S's repeating, and 2 P's repeating. So 11 factorial divided by bracket 4 factorial, 4 factorial, 2 factorial. So you get 34,650. And if you didn't get that number, but you had my other part, it's because you're not dividing correctly with brackets. You need brackets right there. How many 5-digit numbers can be made from 46164? Ooh. Now, what's the difference between what we had before? We never had repeated digits, right? So does everybody see if I switch the 6's around, like if this was 46,164 and I switch the 6's around, it would be the same number? Okay, so it works the same there. So again, how many 5-digit numbers can be made? So how many choices do I have here? So 5 factorial, yes. And then I'm going to divide by the number of repeated. So that would be 2, 2, right? So this would be 5 times 4 times 3 over 2. So I get 30. No calculator for this one. It's too small of a number. Does everybody see how I got 30? Yes? So again, I simplify 5 factorial over 2 factorial is 5 times 4 times 3, and then this 2, 1 cancels. And then 2 factorial is just 2. So then I reduced 4 over 2 to be 2 over 1, and I get 30 there. How many different flag signals can be made using all 5 flags using 3 red flags and 2 blue flags? So this is something like this. It's like a 5-letter word with 3 R's and 2 B's. That's how you should be looking at it. So how would I do that? 5 factorial divided by 3 factorial, 2 factorial. Very good. So how do I simplify that? Again, 5 factorial over 3 factorial can be reduced to 5 times 4, and then the 3, 2, 1 cancel. And then I'm still dividing by 2 factorial, which is 2. 2 goes into 4 twice, so I get 10. How many ways can 5 people sit in a row of 8 seats? So this time I actually have more seats than people. So what's going to happen is the 5 people are going to be stationary and the seats will be choosing the people, if you think about it that way. Which isn't, well, that's the only way you can do it, because again, the objects have to be less than or equal to the positions have to be less than or equal to the objects. So you can't go 5p8. It has to be 8p5. But if you think about that for a second, you have 5 decisions to make, right? You have 8, 7, 6, 5, 4. Either way, we punch her in. We get 8p5. 6,720. Any questions on that one? Okay, using the letters in the word brains without repetition, that means you only have 1 letter of each. How many 4-letter words can be formed if there's no other restrictions? 4-letter words, and how many choices do we have? So does everybody see it would be just 6p4? Or you can do it as I have 4 decisions to make, 6, 5, 4, 3. Because everybody understand the blanks is the same thing as permutations, right? But the permutation function can only be used if there's no restrictions. If there's restrictions, you need to use blanks. So this would be 20 times 18, so what, 360? Yeah? Okay, so as soon as I start making a restriction, you need to go back to making decisions using blanks. So if it ends with an R, that means this 4-letter word, this has to be an R. Do you see that? So you only have 1 choice for that. After you use up that R, how many choices do you have for the first letter or first spot? 5, then 4, then 3. So does everybody see I get 60 that way? What about starting and ending with a vowel? So again, restrictions means I have to use blanks. How many vowels do I have? I have 2. But the problem is well, no, I guess there is no problem. So it has to be an A or an I, and then this would be an A or an I. So if I make that choice first, I either have the choice of the A or the I, and then whatever's left over goes there. Does everybody see? And then how many letters do I have left to choose for the rest? 4, then 3. So then that would be 24. Yes? What happens if I only use consonants? Consonants is all the ones that aren't vowels, right? 1, 2, 3, 4. How many choices do I have? Yeah, you have 24 because it's 4, 3, 2, 1. Yeah? With the vowels and consonants alternating. This is a tricky one, actually. How do I know if I start with a vowel or a consonant? We don't know. We do cases. Very good. So case 1 will be what? Vowel, consonant, vowel, consonant. And case 2 would be consonant, vowel, consonant, vowel. Okay, so how many vowels do I have? 2, then 1. Yes? How many consonants do I have? 4, then 3. So this is 24 and 24. So how many do I have total? 48 total. There we go.